Alright, welcome back to another Ralph programming video. It's been a while since our last programming video, but there's been a reason for that. I've been kind of setting up repositories and trying to learn the language at a very deep level and try to understand what exactly it is that makes Ralph special when compared to Solidity. And honestly, I think that's the big comparison, right? Why would I want to come to Lithium and build on their chain in Ralph when there's tons of other proof of work chains that are just being forked or modified even slightly, and they're just going to use Solidity, or they're going to be a whole brand new chain and just use Solidity anyways because it offers just a wide range of use cases that are have already been seen, right? And so the main reason to use the Lithium, I think, in my own personal opinion, is that a Lithium is something entirely different. And it's exactly as it says on the website. It's a completely different paradigm. And that said, building your own language actually gives a deeper meaning to the level of security that you can have, with the fact that I think you can imply more things, such as the Lithium APS system. That code is a little bit more unique to that system, right? At least in my own opinion. But anyways, today we're going to be doing the Lithium development, and we're going to be making a token contract on and with Ralph, right? So right now I'm just opening up a second terminal and I'm getting ready to update my DevNet. And so I was going to demo this process where I just get pull, and this is basically just going to fetch any changes that have been done to the DevNet, and then I can run them using Docker on my Ubuntu subsystem. And so this is also a good way for Windows and Linux users to actually be able to see that this is possible to run. Now that I'm running it as a Windows subsystem, both Windows users and Linux users can actually see those advantages, right? So here I'm going to do cd devnet because I want to open up my devnet, and then I'm going to do sudo docker compose up. And you don't have to do this, but I find that in my case it is required, as otherwise it won't work properly. So now it'll compile the new changes that we got from GitHub, and it will build out our DevNet. As you see, it's starting to pull those initial containers and initialize the DevNet instance. Once we get down to around, I don't know, it says usually listening WS request. Should be good now. We'll test it real quick to see what it is that it gives us. So we'll run our npm compile on our project, and we have no source files, which is correct. So what we're going to do now is we're going to create a simple token.ral contract, and we're going to start this with using the required imports that are in the Lithium documentation, which I'll now show off. Standards, here we go, fungible tokens. So we have to use these interface options when we're making a fungible token, and we have to have these functions right here, right? So all we're going to do is we're going to take this standard interface, we're going to copy it, and we're going to paste it onto our VS Code. Simple as that. Simple as that. So now we're using this right here, which is that fungible token import. We have our method selector, which is set to false. And here it doesn't mention why there's a method selector, but I believe that is to just imply the interface that is being used. So we'll do this, and we'll do contract, and we'll just call it YouTube token. And then we'll do the following required symbols that this token requires, right? So a symbol is a bytevec, which is a string. We'll do name, which is also a bytevec. We'll do decimals, which is a U256 option or a number. And then we'll use supply, which is the supply of the token that we are going to make. If we wanted to make a faucet, we could set a balance option here and then like export the tokens that have been done. And so in this case, we can do like a mute balance to receive those tokens, and we can say mute balance is U256. And so now we can do all these public functions here after we do implements. And then we say IFungibleToken. And now we can write down all those public functions that we want to use, right? So we'll take all these public functions here and actually, yeah, so this will work here. And we'll just return the required variables. And then we're going to compile that. So let's give that a quick compile real quick and see where we have messed up or not. So we can see that mute balance expects a comma, no biggie there. And we can see that YouTube's token has unassigned mutable fields. So in this case, if we have mutable balance, we need to specify how we're using it, at which point we'll probably make a public function called withdraw, and we will specify no return type on it, and we will say that we are going to take balance equal balance -2, and so we are going to withdraw 2 tokens from the supply that we just created from the supply value here of U256. And then we will do a transfer token from self, and we will take in the to address, which would be the caller address. Whoop. We'll take in the token ID, which it wants next. And so we should be able to say self token ID. These are all built-in functions in the Ralph language, by the way. And so it says right here, returns the token ID or the byteback of the contract. And then we'll just say 2, because that's all that we're withdrawing from the supply. And so now that we have that down, we can either emit an event or we can add the permissions at the top. So what we're going to want to do is we can add those permissions. I'm just going to go grab the permissions from another contract so I don't have to write them all down. Here we go. This should work here. And I'll grab that, and we'll say that there's no pre-approved assets here, but we do update the fields as we are updating that field right there. So that's us updating the field. And that's the withdraw, and it should be good now. As we can see, we have uses contract assets, and so I like that they added this in the compiler, by the way. So we add that assets are being used in the contract, which is true. We are not pre-approving assets or taking any assets, though, away. And then we have the check caller option, which needs to be specified here. So in this case, we will say check external caller equals false, as anybody should be able to call this function as we are not specifying otherwise. And there you go. You've created YouTube token, and bam, that's a token. And so this is a faucet right now. So basically it'll create a token contract, and then we can take from it and export from it and take tokens and move them around. But otherwise, this has been Making a Token with Ralph, and I'll see you guys in the next video. Peace.